Hey guys, so in this video I'm going to talk about how to multiply polynomials. So I want to just be really clear about what I'm going to go through in this video. I'm literally going to go through like everything that you need to know. So we're going to start with kind of this situation. We're going to build up to problem types like these and just kind of really go through a whole breadth of problems. So if there's something specific that you're looking for, you can look in the description of this video. I have quick references if you just want to kind of jump around a little bit. But if you really feel like you need a full brush up or you need some instruction on how to multiply polynomials, we will go through everything here. So I highly recommend you use the free guided notes at divideandconquermath.com and pause and try the examples when prompted. So let's just get started here with this first situation, which I think this is kind of like the most straightforward. So this is a monomial. So this is a one-term polynomial multiplied by a polynomial of any size. So when you have this situation, all you really have to do is distribute, and as you're distributing, you just kind of keep the rules of exponents in mind. So I want to be really clear here about what's happening. So I'm going to multiply the numbers in front. So I'm going to take 3 times the 4, and then for the x's, I'll add the exponents. So this is what's happening as I distribute this 3x to this 4x squared. Here's kind of the mechanics. And I just want to like kind of break this out across the whole polynomial. So as I go across, I'll take the 3 times the 5, and then once again, I'm going to add the exponents here, and then I'll have this minus 7 times 3x. So here's the mechanics of what's happening when I distribute. And so then if I just finish this, this will be 12x to the third plus 15x squared minus 21x. And so that's what it would look like to multiply this monomial with polynomial. Now, I can make this a little trickier and I can have extra variables and more exponents and stuff like that, but it's still the same process. So I highly recommend, if you feel like you've kind of got this, maybe to pause the video here and just do this particular problem. So as I distribute, so once again, I want to be nice and clear here. So this will be 3x, so I'm going to add the exponents, and then I'll have this y to the 4th. Then I'm going to have 2x, and then I'm going to add the exponents again, just like this, so you can see what I'm doing. And then finally, I'll have this x squared, and then this y to the 4th plus the 4th. So here's kind of the mechanics of what's going on in this problem. So this is going to be 3x to the 4th, y to the 4th, plus 2x cubed, y to the 5th, minus 8x squared, y to the 8th. And so you don't have to write out all this detail, but if you kind of struggle with what to do, it can be helpful to write out all that detail, just to remind yourself what you're actually doing with the exponent rules. So I've got one more problem here. So once again, I'd highly recommend that you pause the video and give this a try. So notice that I'm multiplying everything by 1/2, so I'm just taking half of everything. So half of 4 is 2, and then this will be x to the 4th, y to the 7th. So 3 plus 1 is 4, 4 plus 3 is 7. Okay, so half of -2 is just going to be -1. So you can either drop the -1 or you can write it out. It's up to you. And then this will be x to the 6th, y to the 5th. Again, adding the exponents. And then half of 8 is 4, and then this will be 4x to the 4th, y to the 5th. And so that'll be it for that one. Okay, so that tends to be more straightforward. Now I want to move on to kind of polynomials times polynomials. Now, a lot of times you will hear what I refer to as a 4-letter F word, FOIL. I don't actually like this term. So there's nothing wrong with it, but the problem is that people think of just this algorithm, and I can make a problem where the FOIL method doesn't work. And I find that when people really hold on to the foiling method, then they get thrown off when anything else is kind of thrown at them. So instead of using FOIL, this is literally going to do the same thing as FOIL, but I want to show you just maybe a slightly different way to think about this. So the whole idea for all polynomials, regardless of how many terms you have, is to multiply everything in here by everything in here. So let me show you what that looks like. I like to use lines to do this actually. So if I take like x times x squared, so remember you're going to add your exponents there, that's going to give me x cubed. Okay, so that's multiplying the first terms together. Now I know that I am going the foiling process. That's not the issue here. It's more of just kind of understanding what are we actually trying to do. So taking x times 3x, that's going to give me 3x squared. And so now notice what I've done. I took this first term and I multiplied it by everything over here. That's the bigger thing that I want you to notice. So now as I move in towards the 2, so 2 times x squared, that's going to be 2x squared. And then 2 times this 3x, that's going to give me 6x. So the thing I want you to notice is not that we did actually like use kind of the foiling method here, but there's something stronger here. We literally multiplied all of these terms by all of these terms. You can see it now in how I've kind of drawn out the lines. And so I think this is a slightly stronger way to think about things. And so from here, now you can just look at what you're left with and say, can I collect any like terms, which in this case we can. So this will be x cubed plus 5x squared plus 6x. And so then we're good to go. So now I want to just do a couple of examples of this with you. So I'll do the first example with you and then I'll turn you loose to try a couple on your own. So going through this one more time, so if I just think about this in terms of like lines, so I take these, so the x times the x, what's that going to give me? X squared. And then I can move on and do x times the 2. So that's going to give me 2x. And now I've multiplied all of these terms by the first term. So now I can pivot to the next term and take the 3 times the x, so that's 3x. And then the 3 times the 2, so 3 times 2 is 6. So here's what I'm left with in this problem. So this becomes x squared plus 5x plus 6. So very similar to the other one, I've just realized. Okay, so if you feel like you've kind of got the idea down, I highly recommend that you pause here, try B, and then hit play when you're ready. So if I repeat this process again, so 3x times x is going to give me 3x squared. 3x times negative 6 is going to give me negative 18x. 1 times x is x. And then 1 times negative 6 is negative 6. So this is going to leave me with 3x squared minus 17x minus 6. Okay, so once again, I have another one of these for you to practice. So pause the video, give this a try, and then hit play when you're ready. So now I have x's and y's in here. So this one's a little different from what we've been doing so far. So I've got x squared times x is going to give me x cubed. I've got x squared times negative 2y, so this will be minus 2x squared y. 4 times x will give me 4x. And then 4 times negative 2y will give me negative 8y. And so this is kind of the thing that I wanted to point out. You're not guaranteed to have like terms. In this case, we have no like terms. So sometimes you'll just multiply everything together and then that's it, you're done. Okay, so the next problem that I want to show you, so it's very much the same thing, but this has a special name. So I wanted to just show you what happens with this and then tell you what the name is. So if we go through this, so I've got x times x is x squared. I've got x times negative 4 is minus 4x. I've got 4 times x is positive 4x. And then I've got 4 times negative 4, so this is minus 16. So notice what happens in this case. The negative 4x and the positive 4x actually drop out entirely. So I'm just left with x squared minus 16. So I want to go back and just let me erase these lines just so we can focus on this for a moment. So I want to just point something out. This is what's known as the difference of squares. So sometimes you'll see like formulas are brought up for this, but you don't really need a formula to remember this. You can just work it out like usual. But the thing to notice with this is this positive 4 and this negative 4 relationship and how that caused kind of the middle terms to drop out, if you will. So that has a special name, difference of squares. It always looks like this with this positive 4 and this negative 4. But you don't have to necessarily remember a formula to do this. You can just go ahead and multiply it like you normally would, and this result will naturally happen. But I will tell you that at a later point in time, you will probably see this come up again if you're doing factoring in your class, which we do in my class. So this just gets a special name. Okay, so now I want to pivot here to slightly harder problems because I feel like we've kind of got the basics at this point. So for this one, so notice how this is different. X plus 3 and then x squared plus 4x plus 5. So whenever I have someone who's like really pro FOIL, oh, I just want to use the FOIL method. So this is exactly what I mean when I say that it's not great for anything beyond the situations we were looking at. FOIL won't help you here. So, but thinking about multiplying everything in here by everything in here, that principle will always work. So we're going to literally do the same thing where I start with this first term and I'm just going to multiply it by each term kind of going forward. So x times x squared is x cubed. So let's just keep going with this first term. So x times 4x. So that's going to give me 4x squared. And then x times 5. So x times 5 is going to give me 5x. Okay, so now I can see I've multiplied x by everything in here, so I can pivot to the 3. So now if I take 3 times x squared, that's going to give me 3x squared. 3 times 4x is 12x. And then 3 times 5 is 15. And so now you can collect any like terms. So this is going to give me x cubed plus, let's see, the 4x squared and the 2x squared will give me, or sorry, the 4x squared and the 3x squared will give me 7x squared. 5x and 12x will give me 17x, and then we've got the 15. Okay, so if that makes sense to you, then I want you to pause the video and try this. So it's still the same idea, but it's going to take you a minute to get through. But if you get how to work this particular problem out, then you can feel pretty confident that you really understand kind of how to multiply polynomials together. So pause the video and hit play when you're ready. Okay, so I'm going to do exactly what I was just talking about, where I start with this 2x squared and I'm going to multiply it by everything in here. So 2x squared times 3x squared is going to give me 6x to the 4th. Remember, you add the exponents. And then 2x times negative 4x, that's going to give me negative 8x cubed. So sorry, 2x squared times negative 4x, so negative 8x cubed. And then 2x squared times 2 will give me 4x squared. Okay, so now I've multiplied everything by the first term. So now I'm going to move on to this 3x and I'm going to repeat this. So 3x times 3x squared is going to give me, so I'm going to go to the next line here. So let's make this 9x cubed. 3x times the negative 4x will be negative 12x squared. And then 3x times 2 is 6x. Okay, and so now we've multiplied 3 against everything in here. So now we just have the 1, and we have to multiply 1 by everything in here. So 1 times 3x squared is going to give me 3x squared. 1 times negative 4 is minus 4x. And 1 times 2 is 2. Whew, it's a lot of work, right? So now we can go ahead and add all of these up, and you can kind of add these out however you want. So let's see, we're going to start with 6x to the 4th, so I'll go ahead and cancel that out. Then I've got the negative 8x cubed and the 9x cubed, so that's going to give me just x cubed, so I can cancel those out. Then I've got 4x squared minus 12x squared, so this is negative 8x, and then negative 8 plus 3 will give me negative 5x squared, so those all cancel out. Then I've got 6x minus 4x, so that's 2x. And then finally the plus 2. And so there's the answer. So that one definitely requires a lot of work and organization, but I think if you kind of use like these lines as a visual marker, that is just, I think it's just a lot stronger than only having the FOIL method at your disposal. Okay, so now what I want to do is I want to pivot to just a slightly different type of problem here. So now I've got x plus 5 squared. Now a lot of times people think that you can just go ahead and distribute this 2 like this, but we actually don't have a rule that says that. The rule that people are kind of thinking of is this xy squared. So this is the rule where you can actually distribute the exponent, and this will give you x squared y squared. But we don't have a rule that says if you're adding 2 things that you can distribute that exponent in. So instead, we have to think about what does it actually mean to be x plus 5 squared. And when you square something, that means that you're multiplying something by itself. So in this case, this is going to be x plus 5 times x plus 5. And when you think of the problem like this, now you can see that you've actually got to go through and multiply, or if you're still really holding on to the FOIL method, FOIL it out. However you want to think about this, you have to finish multiplying this. Okay, so let's go ahead and do that then. So I'm going to have the x times the x, which is x squared, x times 5, which is 5x, 5x, and then we'll have 25. So there's everything if I multiply it all together. So I get x squared plus 10x plus 25. Now, once again, a lot of books will actually try to give you like a formula of how to do this, but I'm very anti-formula. I don't think you need a formula to remember how to do this. All you have to remember is that you have to write this out twice and then just multiply it together like you normally would. So just to give you a chance to practice this, I have two problems like this if you want to try this a little bit more. So you can pause the video here and then hit play when you're ready. So if I rewrite this as x plus 2 times x plus 2, so I should get x squared plus 2x plus 2x plus 4. So this will be x squared plus 4x plus 4. And I have just one more. So again, if you're trying to practice this, you can pause the video here, hit play when you're ready. So this is going to end up as 2x squared plus 1 times 2x squared plus 1. So if I multiply all those things together, I get 4x to the 4th plus 2x squared plus 2x squared plus 1. So this comes out to 4x to the 4th plus 4x squared plus 1. Okay, and so for the final part of this video, I want to talk about the last situation that you can kind of encounter with when you're multiplying things together. So what do you do when you're multiplying 3 polynomials together? Well, if you think about it, like what would you do if you were doing something like 2 times 3 times 4? Well, in your head, you would choose to multiply two things together. So for instance, I might go like this first. So I could do like this, so this would be 6 times 4, so this would be 24. Or, you could also do if I'm doing 2 times 3 times 4. So in my head, I could also say, oh, I'm going to multiply those together first. This becomes 2 times 12, so this equals 24. So what you would do with numbers, it's really the same thing that you're going to do with polynomials. So you can decide where you want to start. You can either multiply like these two together, or you could multiply these two together. It doesn't matter. But you first start by multiplying one set of parentheses together, and then you bring the other set in at the end. So let me make some space. And I personally like taking always the last two binomials, I guess. So I'm going to start by multiplying these together. So I'll write the x plus 2 down again. And now let's go ahead and multiply this together. So this becomes x squared minus 3x plus x minus 3. So what you're going to want to do is you're going to want to simplify this polynomial as much as you can. So this will become x squared minus 2x minus 3. Okay, so now that I've done that, now I need to multiply again this times all of this. So now I can take the x times the x squared, so this will be x cubed, x times negative 2, so this is minus 2x squared, and then x times negative 3, this is minus 3x. Then moving on, I've got 2x squared, so this will be 2x squared, 2 times negative 2 is minus 4x, and then 2 times negative 3, that's minus 6. And so now if I collect my like terms, I get x cubed. Let's see, these x squareds actually drop out. I've got minus 7x, and then I've got minus 6. And so that would be how that all multiplies together. So I have just one more example of this if you want to try this on your own. So you can pause the video here, multiply this together, hit play when you're ready. So once again, I always just, by force of habit, I always just like to multiply the last two binomials together first. So this is going to be x minus 3. This will be x squared plus 4x minus x minus 4. So this will be x squared plus 3x minus 4. So now I can start multiplying all these things together. So let's see, I've got x times x squared, so that's x cubed. X times 3x is 3x squared. And then x times -4, so that's -4x. -3 times x squared is -3x squared. -3 times 3x is minus 9x. And then -3 times -4 is positive 12. And so now in combining all this, I get x cubed. My 3x squareds drop out. This will be minus 13x. And then plus 12. And so that's it for that one. And so that's really your complete overview then of how to multiply really any type of polynomial together. If you are interested in seeing more examples, you can always email me or leave me a comment, and I am more than happy to make more example videos, or if you have questions, you can always leave a comment. Otherwise, thanks for watching, guys. I'll catch you next time.